Hello class. Today we are going to be looking on using the Pythagorean theorem to show that the following set of numbers, three numbers, actually form a Pythagorean triple. I'm going to use the lazy way and I'm going to write PT in this video, Pythagorean triple. So let's look at the first set of numbers here. We have 8, 17, and 15. So the first thing you want to do is you want to write down the numbers and give them the names A, B, and C as we use in the Pythagorean to plug them into the Pythagorean theorem. So we have A equals B equals C equals, and that's going to go into the Pythagorean theorem, which is a squared plus b squared equals c squared. So if we actually plug these numbers, the one that we want to pay attention to is the c, which is the hypotenuse. That has to be the biggest number right here. So that's our c. And A and B doesn't really matter which one is which, but I'm going to go with 8 is A and B is 15. So the next thing we want to do is we want to plug these numbers into their into the letters that they represent. So instead of A squared, we're going to put 8 squared, and instead of B squared, we're going to put 15 squared. For C, we are going to be putting 17. Oops, I made a mistake there. So C is 17. Sorry, 17. So we're going to put 17 squared in for C. Now we will square these numbers. So 8 squared is 64 plus 15 squared is 225. And c squared, or 17 squared, sorry, is 289. You can use a calculator, or hopefully you memorize the squares of numbers 1 to 20. So now let's add the left side. The right side is already done. Let's look at the left side. So we need to add the 64 and the 225, and that would be 289 equals 289. So in this case, both sides are correct. So this equal sign actually comes true. Not always the case. If it is, we say this is, so the numbers 8, 17, and 15 are a Pythagorean triple. Okay, because the left hand side equals right hand side, and that's not always the case. Let's look at the next example. Somebody might say this and right away tells me this is not a right angle triangle, so therefore it's not a Pythagorean triple for one reason, but we'll talk about that at the end. Let's prove it using the Pythagorean theorem. So in this case, we have A equals, B equals, and C equals. Somebody would say right away that, well, all of them are 2's, so there is no hypotenuse, therefore there is no right angle triangle, or not a Pythagorean triple. But let's use it as if this number was a different number, like 3. Let's plug the numbers into the equation. A squared plus b squared equals c squared. So we put these numbers in. 2 squared plus 2 squared equals, and c is also 2 squared. The c part, c squared is going to be 4, and here we're going to end up with 4 plus 4 when you square both 2's. So you're going to end up with the left side is 8 equals the right side 4. Obviously, that is not true. Therefore, you can say this is not a perfect square. Not a Pythagorean triple, not perfect square. different lesson. Not Pythagorean triple. Okay. Now you can practice this on your own. Here are some questions to practice. The answers are going to appear in a few seconds, so if you want to pause the video now while you try these. The answers are, the first one is not a perfect square, the second one is not the Pythagorean triple, the second one is a Pythagorean triple.